So in this topic, we are going to learn what is defined by colloid and surface chemistry. Colloid is a mixture of two or more substances. It can be either in a solid, liquid, or gas phases mixed together but not chemically combined. Colloid also can be defined as a mixture where tiny particles of one substance are scattered through another substance, or we call it as a medium. So in this case, we have here, in comparison with true solution and colloidal solution as well as the suspension, we can see the particle size for true solution is about less than 10 to the power of minus 7 centimeter. For the particle size of colloidal solution, we have the particle size here is in the range of 10 to the power of minus 7 to the 10 to the power of minus 5 centimeter. So for the particles in the suspension solution here, we have the particles size is greater than 10 to the power of minus 5 cm. Now let's take a look at the characteristics of a true solution, colloid, and suspension. We can differentiate the characteristics in terms of their own properties. Here we can have here, for the first one is the particle size. For a true solution, we have the particle size is much smaller, which is less than 1 nanometer. And for the colloid is in the range of 1 to 100 nanometer. And for the suspension, we are having a larger particle size which is greater than 100 nanometer. So this particle size can be separated from its medium by using separation technique. And here we have the ordinary filtration and ultrafiltration. So for a true solution, they are not possible to use both of the techniques because the particle size is forming a homogeneous solution with the medium. And for the colloid, it is not possible to use ordinary filtration, but it is possible to use ultrafiltration. In this case, we can use polymer membrane to separate the particle size. And for the suspension, it is possible to use both of the techniques because the particle size is much larger. So for the settling behavior here, we have a true solution that does not settle easily. And for the colloid can be settled only by using centrifuge technique, and for the suspension can be settled easily under gravity. For the appearance here, we have a true solution is more like a clear crystal solution. For example, here we can have a drinking water, and for the colloid here we have a generally cloudy solution. Example here we can have a milk water, and for the suspension having a little bit cloudy, so we can have here, for example, a flour mixed with water. For the diffusion, here is a true solution diffuse rapidly and colloid diffuse slowly, but suspension do not diffuse because they are having a larger particle size. So for these three characteristics of a true solution, colloid and suspension also behave differently according to their own Brownian motion and Tyndall effect. Different type of colloids will behave differently according to their dispersed phase and dispersion medium. So example here we have the solid as the dispersed phase and we have the solid as the medium. Okay, mix this together, it can be called as a solid salt. Example here we can have alloy, gemstone, and reinforced rubber. Example here we have a liquid as the dispersed phase and we have solid as the medium. So when this liquid is put into solid, we can call this as a solid emulsion. Example here we can have cheese and butter, and in the example we can have a gas as the dispersed phase and dispersion medium is a liquid. So this one can be a foam. So the example we can see from the whipped cream and shaving cream. Brownian movement, or also called as a Brownian motion, is defined as the random motion of particles in dispersion medium which arise from collisions with the fluid molecules. In this case, the size of the particles is inversely proportional to the speeds of the collisions. If we have a size of the particle is much smaller, meaning that the speed of the collisions among the fluid molecules is increasing. Lighter particles obtain greater speeds from the collisions. So the speed of the collisions also is inversely proportional to the viscosity of the solutions. Viscosity here means that the measurement of the fluid's resistance to flow. Increasing the speed of the collision among the liquid molecules, meaning that the viscosity is less. So the Brownian movement also causes the particles in constant motion. Thus, it prevents the particles from settling down. What is Tyndall effect? Tyndall effect is actually a phenomenon in which the scattering of light by particles and is often used to distinguish between a colloid and a true solution. An example here, when we have the light source and when a beam of light passes through these three solutions, there should be a cone of light when observed at a right angle. Okay, this is the cone. And if we can see from here, if the size of the particles in the colloidal solution is large enough to scatter the light, so the light will be reflected from the original beam path. So it needs a particle size which is larger to scatter the light. For the solution, a true solution here, we have no observation for the scattering of light. Okay, there will be a scattering of light between the colloid and suspension.